Okay, so we've got this tension problem. We're trying to find the tension force in this rope here. Okay, and so let's do it from the beginning. I'm going to erase all this. If we take this and we flatten it out, it's going to look like this, and it's going to be a tug of war, right? If we use, are you okay if I use G as 10? Okay. So this would be 250 newtons, yes? And this is 120 newtons. And if you're mathy, you would want to make this negative. How many people got that far? Okay, good. So these are forces of gravity, but we're just drawing it sideways because they're pushing against each other. Okay, how would I find my net force on this? Con. Good. We're gonna, if you're mathy, we're gonna add them together. And if you're real worldy, you're gonna do like Con, and you're just gonna say this one wins, and it wins by 130. Is that right? So my F net is my FG on my 12 and my FG on my 25, and that's going to be 120, or sorry, negative 120 plus 250, and that's going to be 130 newtons. Now that's the net force on the system, right? So sometimes you might want to say system like this. Archer, let him in. Poor Taha. Hi Taha. I stuck up for you. But you just bang on the glass, so I'll make sure you. So this is my net force. What are we gonna do with that? Where do we go from there? Yeah, good. As Maddie says, we're gonna find the acceleration, so we're gonna say F net equals ma. And so I'm going to solve for A by dividing my mass underneath. And so I'm going to take that 130 newtons. And Ivan, which mass am I going to use? Yeah, we're going to use the total mass, right? You can add them together. This is going to be 37 kilograms. So that's like 3.8 or something like that. 3.5? Put your hand up if you got 3.5 for the acceleration. That's good, that's good. Okay. So most of you are at that point. Now, here's the thing. You got this acceleration, right? That's the acceleration of the system. Does that mean that it's the acceleration for this block too? Maddie's nodding her head. Yeah, it is. Is it the acceleration for this 25? Yes. Because they're tied together, right? So it has to be all the same. So they have all the same acceleration. Okay, fine. We have acceleration. It's the same acceleration. So I'm just going to write this down because this is the key to solving these problems, is acceleration is the same for each block and for the system. That's the first thing you want to key in on. And the second thing you want to key in on is that the net force is not the same. So the net force on each block and the system are all different. if you think about it, you'll know it kind of has to be like that. Because if the acceleration was the same and the F net was the same, then everything would have to be the same mass, which it can't be. So the acceleration is the same for everything, but the net forces are different on the system and on each block. So we calculated the net force on the system, but not on each individual block. Okay, so I know it's getting boring and I'm talking at you a lot. You're doing very well. I'll wrap it up very soon. Okay, I'm going to draw the system sideways again, and we have 25 and we have 12. Okay, let's focus in on one block only. Which one do you want to do? 12? Okay, let's look at the 12. Actually, I'll draw it like this. So this is 120, right? Okay, so we have 120 going this way. Is the 12 the winner or the loser? It's the loser. Poor 12. That means that the tension has to be bigger. It's going to be bigger than the 120, right? Because the 12 has to lose. How can we find this tension force acting on this block? Omar, you got an idea?
Yeah, we can use the acceleration as the negative acceleration because it's accelerating.
Is it a negative acceleration?
Well, if we're saying the 120 is down and it's positive.
Oh, this is negative, isn't it?
Oh, okay.
Yeah.
Then it's a positive acceleration.
Good. Yeah. So we're gonna find the net force, but this time it's not the net force on the system. It's the net force just on the block. So it's just the net force on the 12. But because acceleration is the same for everything, we can use the same acceleration. So we're going to do 12 times our 3.5, which we calculated before. So that's going to be 36 and 6, which is 42. Right? Okay. Now we have the net force on this block. It depends, this next part depends if you're mathy or if you're real worldy. If you're real worldy, you're going to say, I know this tension force wins, and I know it wins by 42. So it's got to be 42 more than 120. So it's going to be 162. If you're mathy, you're going to be like, no. We have to be. We're going to say the net force on this 12 is the sum of the forces acting on that block. So we're going to say it's Ft plus Fg. And then we're going to solve for this Ft, so we're going to have to subtract our Fg over. And so this is 42, right? And then we're going to subtract negative 120, and that's going to give us 162 newtons. What I want you to do right now is take a couple of minutes and do this exact same thing, but do it for the other block and calculate that force of tension. It should be the same, unless we made a mistake and did something wrong. I don't think so. Did I already take attendance for you guys? Okay. Just do it on the boards here so I can shut off the movie. if you get your answer and it's a little off, it's just a rounding error because we used 3.5 and not like all the decimals and stuff. So if it's like a little bit different, don't worry, that's fine. But they should be the same, and one should be positive and one should be negative. I've talked at you for far too long now. I'm going to turn off this